welcome everybody. My name is Frank. Ulrike is sitting somewhere, and this is already my first comment. It feels more like a rock concert than a conference to me, because I'm blinded by the lights, to speak in Manfred Mann, and I'm just missing my bass guitar to go to this. And okay, so you can help me get this feeling of rock concert by cheering in the middle of the conference. And so I want to take you on a quick journey about accessible and tagged PDF with LaTeX. By the end, then Ulrike is in the talk as well, so I hope we can then answer all your questions, or she can, if I can't, which is likely. So let's go. Here's kind of the scenery. I give you a bit of background on LaTeX because not everybody in the audience might know that tool so well, in contrast to, I guess, PDF. I will also talk a little bit about PDF then, and the challenges and the resulting opportunities around that. And so let's start. LaTeX itself has a very long history. It predates what we know as the internet. It was originally there, then later a lot of concepts evolved, and many of them actually drew from what LaTeX already did for years, and you can trace that back in various places. So that's kind of interesting to see. The first version of LaTeX appeared around '84. This was all targeted to high-quality printing and not much more, not even viewing back in the days, because not many people had possibilities to view something on a screen, because the screens were just usually not good enough or too expensive to have these kind of things. So it was all about printing. By around 1990, 1989, I had pestered Leslie Lamport enough so that he threw the whole thing on my feed and said, you can do it from now on. And this is in some sense what happened. The basis of what you today use as LaTeX is actually also pretty old. In 1994, the LaTeX project team developed a new version of LaTeX called LaTeX 2 Epsilon. And this is still what is at the core of what is used today. Nonetheless, there has been a lot of development and enhancement, but until very recently, it was not the kernel that changed, but it was all kind of additional packages that got developed and things that got added in various ways. The core stayed stable. The use today, we have LaTeX very widely around the world. Just to give you a small figure, our LaTeX project website has about 10,000 hits per day, and these are mostly new users. You can see the peaks when the university semester starts, then it goes to 20,000 for a while. And these days, this was not always the case, obviously, because PDF wasn't around when LaTeX was developed. These days, PDF is sort of the standard output, sometimes through different workflows, but also often very directly. So you have a LaTeX source and you get immediately PDF out. There are other ways going through PostScripts, workflows that have been developed over the years and are still there. It is, you can say, the predominant lingua franca for publishing and writing documents in many of the STEM disciplines. So if you are in mathematics, computer science, and many others, you are expected as a student to use LaTeX. And there are, well, I just gave the numbers here, more than 2 million documents of preprints in the archives.org archive. There are numerous journal styles for writing your thesis, styles for writing your thesis, styles for writing to Springer, and so on and so forth. So there's a lot in those areas. But it is not restricted to what it is very known for, doing very good mathematics, for example. It is basically used in every corner of publishing, you can say, or printing or development of documents. You find it for people writing critical editions. You have game typesetting like chess, Go, what have you. You have, and this is a very strong feature, you have workflows in places where you do database publishing. So you have your database and you do automatic publishing, and then at the back end there is something like LaTeX going on. For example, I don't think that's the case anymore, but the German railway charts were actually done with TeX. I don't think it was LaTeX, but it was TeX for a long while. Yeah, we have these days more than 5,000 extension packages, which is, well, which shows how widely people have driven things, but also, of course, causes certain kind of problems in some areas. The LaTeX strengths, and I can only give you highlights, but the most, I say, important one is the idea of writing structures. So you don't write your visual document, you write what the semantic intent of your document is, and that allows you to do reuse and repurposing, as well as different layouts and so on and so forth. But the other thing which is important, you are able to override these kind of automatic formats by adding additionally very precise formatting instructions. Of course, then reuse becomes a challenge, because then you have your processor information, if you like, put in. But the balance of it allows you to give you very, very high quality if you need to target highest quality. So you can get high quality with reuse, and you can get even higher quality if you drop some of the reuse possibilities because you're publishing a book or whatever, and this is where it becomes very important. Features also said high quality typesetting, and in certain areas it is absolutely unsurpassed by any other tool that is on the market. The other one is long-term compatibility. This is also something which LaTeX is very strong at. If I try to reprocess my thesis, I can. It still works. It still comes out. And this is something you cannot say from many other tools. And this is what people expect. LaTeX users expect, I mean. The other one is it is programmable. You really, in some sense, are programming your document, and this also makes it accessible, and this is the reason why, extensible, and this is the reason why we have so many extension packages, because you can say, okay, I have a new domain, I want to do X, Y, Z, and you can actually start programming that and turn it into an extension to the LaTeX system, and from there on it is going to be used. To give you just some examples rather than talking more about this, this slide is all typeset. It is not graphics. Nowhere on this slide is graphics. I mean, no, I'm lying. This is graphics, because each and every one was a separate document, and I had it copied and then put it as graphics on this screen. But effectively, what you're seeing here is typeset material, structured typeset material. So the chessboard is actually produced by writing down the moves and then say, print current position. Well, you can also say, here are the positions of, this is another way to get to the same thing, say, this is the starting position, and there are the things. But the point is, this is structure, and whether it comes out like this or comes out differently is then a method of the process in the end, but you can reuse this. And this goes for everything else. I mean, this summation sign is if you are on Halloween, you can tell LaTeX to produce certain signs differently. It's still an ordinary sum symbol, and it is doing the mathematics correctly. So this, as a kind of weird example, a little bit more ordinary, and maybe this is looking a little bit shocking for somebody who has never seen LaTeX. You have a lot of backslashes in the LaTeX source. These introduce commands, and you have curly braces to introduce arguments. But basically, if you look at it without telling you much, you can see structure, and you can easily sort of deduce what these structures means, what are the headings, what is a list, and so on and so forth. The only thing you may be a little bit surprised about is this one, Kant. And this is one of those extension packages. It produces random text in Immanuel Kant's style of writing. And that helps me to give you an example which actually has a lot of text which I couldn't put on this slide. So this is basically helping me to show you what the outcome is. This is looking like this. And a few points to note. On this first example, this is just running the last slide through LaTeX. You see Kant has spoken. There's a lot of Kant text there. You can also see that I haven't given a source date, but you now see a date being added to the document. There are various elements which have now numbers, like the headings are numbered, the equation has a number, the figure has a number. Well, they are all 1 or 2 because it's a short document, but they are automatically handled. And you see a reference to the figure which says, take a look at figure 1. And keep that in mind if we look at the second example. Internal links are not colored. It says here, it is colored. It was colored at some point. Okay, never mind. But we have references back from here to the figure number. We have external reference like the URL, and you can make them actually active in the sense that you can go from the document to that place. And this is also handled automatically. In the source, there was just saying this is a URL. Okay, so we make a change now. I had this called a style called demo 1. And the only thing I changed in the source document is now to say use demo 2. And if I do this, the same document comes out like this. Now, there's a lot of differences. You see 2-column, you see different fonts. The equation number is now on the left. A lot of changes because the structure itself is known to the process, and therefore it can make changes intelligibly. And interesting for you maybe, here's the blue ones. These are now blue. The links are marked blue. And you can also see, take a look at figure 1 on the following page. So LaTeX was able to deduce that the figure is 1 page further down, and the textual representation of this was now actually automatically given. This is no change. I mean, this is a style decision. It could say figure 1 on page 2. It could not do anything like this, but this is kind of automatic because the structure is known and well preserved. Okay. So let's switch from LaTeX to PDF. I guess you all know PDF very well. I just heard Matthew talking about some challenges, so I don't need to necessarily repeat a lot of them, but I will focus on a few that are important for the talk that I'm giving here now. Basically, PDF started out as a page description language focusing on print. And that was a very precise thing to do. Everything was marked like I looked at this in the picture. I looked at precisely where the ink should go in this and where the blocks of metal should be placed so that the outcome is very precise. And exactly this is what PDF started out with. Semantic information was of no importance. There was no semantic information in the original format. It was specifying where the ink goes. At some time later, that was added as a separate tree, but effectively, my claim is it wasn't taken up very much, and there are good reasons for it, why it was not taken up very much. I'm not going into it, but this is just the case. It was there, but it was basically too complicated to use and too unclear how to use well so that it makes sense. For LaTeX, I can say none of what LaTeX is producing uses this structured tree at the moment. So it is precisely this page-oriented output, and that's it. And what this project I'm talking about here today is about to change is to make that a history and allow us to actually make good use of the fact that LaTeX knows about structure. So, change of scenery, is this an opportunity or a challenge for LaTeX? I mean, the pressure is growing. More and more there are requirements or even strict regulations that you have to produce accessible PDF. And if LaTeX is just producing print PDF, that's going to be a problem, as with any other tool that is not able to do this very well. So, what's the opportunity? Can we pick the low-hanging fruits? LaTeX knows the structure. So all we have to do is we pass it on into the PDF, right? So what's the problem? Well, it's like with this picture. You put on gloves or you really get hurt. This is for my garden. We just got this about a number of those things, and you really have to be careful with some of them. Yeah. So the opportunities. LaTeX is focused on structure. So we can, and it is programmable. So we can produce with right kind of program, meaning LaTeX, we can produce PDF with the structure tree inside. So we can do this, and we could do it automatically to produce even well-tagged PDF. And PDF that is compliant with various standards as far as you can do this automatically. I mean, some of the standards like UI has this portion which is human, requires human interaction to actually decide whether it's right or wrong. I mean, LaTeX cannot do that for you either. But beside that, the other part should be possible. So if we are able to do this, then it means that new documents can be made automatically accessible to that extent that you have to look at, say, colors, and so these kind of things separately. And no need to post-process, which is the big problem. I mean, at the moment, most of the time you have to do post-processing on the PDF, which means any change from source to the end product means you have to re-post-process. And here we can get away from this. And even for existing documents, we should be able to do more or less the right thing if missing data is being added. I mean, there is some stuff that LaTeX currently doesn't have in its structure because it is not necessary for print. So, for example, alternative text is something that no LaTeX source contains because up to now it was not an important aspect of the process, and therefore it's not there in old documents. So if you want to make an old document then accessible, you would need to go in and add these missing parts which are simply not there. But other than that, that should be also possible to get all kind of older documents working. But, yep, every nice flower has a little thorns in various places. And so there are difficulties, and we have to overcome them, and I'm going through the list one after the other. The first problem is there are conceptual difficulties. The LaTeX tag model is hugely richer than the PDF tag model, even the PDF2 tag model. So we have to find ways how to work out how to translate the LaTeX model into a restricted PDF model, figure out what kind of compromises are possible and what kind of compromises are making the best solutions, basically. There are various ways for it, but obviously not everything might be the right thing. The other possibility, and this is part of, if you like, of the project, is also discussing, well, do we have to think about extending the tag concept in PDF in certain directions if we want to go beyond what is currently possible, because that's actually out there in real life. And LaTeX is just an example that makes it very visible, but effectively it is showing problems, I would say, that are inherent in various document formats out there if you really want to make reuse of the data in the future. So the other problem that we have and will have to solve is because of the extensibility of LaTeX, users can define new structures. And then you have to have a mechanism built how to give the user a choice of also incorporating these new structures in reasonable ways into the whole model so that it makes sense later on for post-processing like reuse and extraction and accessibility. So this is a task that is for us a very important one because of the flexibility that LaTeX offers there. Then this is the opposite direction. There's also missing functionality in LaTeX. as I said, we don't have anything like alternative text because that was not necessary. So what is necessary now is we have to make an interface so that these kind of things can be specified. And this is, as part of the project being resolved, we now have the concept of certain standard key value interfaces that are available or going to be available as part of the project in certain elements, and then you can specify that as part of the source, which means reprocessing the source is not going to lose the stuff because it's not done at the end, it's done at the beginning. The other area where LaTeX is, well, faulty is the wrong word, but not very, very strong, is the question of specifying metadata. Because again, that wasn't so important in the past. It is going to be more and more important now. And we have to find a good mechanism to, again, put that in the source and not put it in the final product. Again, this is resolved / work in progress. We have now an interface. We have to work on how the internal parts or the external user-facing parts of that interface are going to finally look like, but conceptually that's there. And then there's another one, as one of the bigger problems we have. The LaTeX table model is extremely visual, and it is not really structured. That's more a visual structure that is presented. It's not data structure. And if we want to get beyond that step, we have to think about a different data model for tables in LaTeX and presenting in the source of that data model. I would say this is work in going to be processed, to be honest. We have a lot of ideas, but it's not yet there in any way. Different type of problems is the technical problems, because we are going to program from text source to PDF, and there are technical issues. I'm going not to bore you with the details here. I'm just saying the technical problems actually have been resolved in the first phase of the project as far as possible. The full range of Unicode is an issue you can't solve. Is this for the speaker? I hope so. He hasn't used it in, I get corona or something. I don't know what you bring with you. It's all fine. Yeah, I'm not going to go into details here. Basically, we have resolved all of them. The Unicode one is something like this. TeX was invented in the 70s, basically. 77 it was started, and then go on, and later came a little bit later. Unicode wasn't quite there at this time, and so TeX was actually originally a 7-bit engine. Then it became an 8-bit engine, but 8-bit is still not very much in terms of Unicode. And the predominant TeX engine that many people use is called PDFTeX, which is still an 8-bit engine. And in 2018, maybe, we have changed LaTeX to always use Unicode as a basis. But in 8-bit engines, that required some tricks because we are actually not seeing Unicode characters. We are seeing 8-bit sequences of characters. So a Unicode character is a number of 8-bit tokens, and that's a bit different from a single token representing a Unicode character. And this gives a restriction. So basically, you can say the second issue is resolved if you use a Unicode-aware engine, of which we have nowadays 2 in the tech world. And if you are sticking with the 8-bit engine, then some things don't work. Tough. I think by the end of the day, one of the Unicode engines will win the race, but right now it's a mixture of processes, and many use PDF tag and some use Lua tag or CTag, which are the Unicode engines. And then there are process flows with processors going through not PDF directly, but going through PostScript. In some sense, because of historical reasons, sometimes there are advantages, and these pose other problems. So this is the third one, but we have gotten around those. And finally, we have ecosystem consideration. These are more like the soft stuff. And the soft stuff is usually, as you know, the most problematical one. Okay. It's strong for compatibility, I already said that. And the core originally was designed very long ago, and therefore it was targeting for speed. So LaTeX, at the current point in time, tries to forget about structure as fast as possible. And now we want the structure at the very end. So we have to do a lot of reworking. And that's a problem because there is a lot of internal code that needs to change, and a lot of the extension package hook into this internal code. So as a result, if we take those two together, it means any change breaks a lot of stuff out there. Yeah. And given our user base and the expectation that everything works and continues to work, that is a really strong challenge to make this work. But it's essential. I mean, you can't get on without doing that. And so we have to implement that very, very carefully with a lot of mediation going on to make sure that the user base is not getting frustrated because everything breaks around them. And if they are not taking it up because they are fearing that, that will be also cool. But it's possible, and some of the success stories are down on the slide. I'm not going over them very much, but we have introduced UTF-8 as the default. We have introduced a new programming layer that helps us internally a lot, and it works without anybody really noticing it, which, by the way, for people who know about LaTeX history, LaTeX 3 was the idea to produce a new version. It was 20 years before its time because it would have taken a day to process a document. Nowadays, the computers are so fast that we can actually use the ideas from early 90s, and this is what happened recently. And we have a lot of those other things added so that we can now go on and start doing the real work like the tagging without getting too much of a problem. So here's the roadwork of what happens in the project. We planned for 6 phases, and I told people it will take about 4 to 5 years in total, and they, yeah, sorry. It comes from the fact that this is the problem. The problem is not to make it work that everybody comes with you and not stops going with you, and everything continues to work. We are currently at the end of phase 2. The phases are being made in a way that we try to make tangible advances that people can actually use and have benefit from. And of course, in a way that we try not to break things too badly on the way. And so let's go. Already said this. The milestones for phase 2, we have standard hook management. We have the whole PDF object management being done. So if you want to tag a LaTeX document manually by adding the necessary commands, you can get a fully tagged document absolutely working, everything being as it should. But of course, we want to take it one step further. We don't want to put the user in charge of adding this tagging. Nobody wants that. So that's part of it. We have already started doing the automatic tagging, for example, for paragraphs, and those kind of things are fully working in the background. We are currently working on getting a basic set of standard, like the example of the first example document, not the one with the graphics, but the one with the with the lists and footnotes and those kind of things being automatically working. So this is the current situation. Here's a first example. We can't do a live demo, so this is just screenshots from Acrobat. In that case, you see the document earlier. On the left, there's the tagging of the title. You see some of that. On the right, you see the tagging of a list. You can also see, you don't see it here, but the footnote is breaking the links over several lines. It's still absolutely correctly recognized, correctly tagged. What's the last one? Tagging of a footnote. Yeah, you see here the example of the footnote. Yep, and this brings me already close to my talk. End of my talk. There is some useful information on our project site. We have the feasibility study that actually started the project, where we put in, I think, about 40 pages, detailed conceptual ideas how to make things work, including project plans and ideas how this could be put together. There are talks and articles and those kind of things on our site as well. This is the link, but you find it if you just go to the LaTeX project.org and then search a bit around. It's not too complicated. And as far as the PDF association is concerned, we run a LaTeX liaison group, currently about once a month, where we try to connect and learn from you guys. And right now the work that is being done is trying to map the LaTeX model in reasonable ways. I tried to explain what I meant, because the model is richer in certain parts, into the PDF text structure, so that we have a common understanding of what we are aiming for and how that should be best addressed, and understanding how current processors would then interpret this. I mean, it doesn't help if we do something correctly, but the whole tool set out there is then choking on it because it is completely new. I mean, eventually it might be the right thing to do, but then we have to introduce new ways of using text structure in the tool sets out in the world, which actually I think is necessary as well, because in some cases it is so much on heuristics and things being done because it was always done like this, or there was no better way initially, and so there is a two-way street, really. That liaison group is open to PDF members, of course, and I guess we will be happy to see more participants there.